3.7 Scatter plots, the sample covariance and the sample correlation. What is the relationship between age and earnings? This question, like many others, relates one variable, big X age, to another, big Y earnings. This section reviews 3 ways to summarize the relationship between variables: the scatter plot, the sample covariance, and the sample correlation coefficient. Scatter plots. A scatter plot is a plot of n observations on big X sub I and big Y sub I, in which each observation is represented by the point open big X sub I and big Y sub I close. For example, figure 3.2 is a scatter plot of age open big X close and hourly hourly earnings open big Y close for a sample of 200 managers in the information industry from the March 2016 capitals CPS. Each dot in figure 3.2 corresponds to an big X and big Y pair for one of the observations. For example, one of the workers in this sample is 45 years old and earns $49.15 per hour. This worker's wage and earnings are indicated by the highlighted dot in figure 3.2. The scatter plot shows a positive relationship between age and earnings in this sample. Older workers tend to earn more than younger workers. This relationship is not exact, however, and earnings could not be predicted perfectly using only a person's age. Sample covariance and correlation. The covariance and correlation were introduced in section 2.3 as two properties of the joint probability distribution of the random variables big X and big Y. Because the population distribution is unknown, in practice we do not know the population covariance or correlation. The population covariance and correlation can, however, be estimated by taking a random sample of n members of the population and collecting the data open big X sub I and big Y sub I close I equals 1 through n. There's figure 3.2, a scatter plot of average hourly earnings versus age. Average hourly earnings are on the vertical axis from 0 to 120 and age from 20 to 80. Each point in the plot represents the age and average earnings of one of the 200 workers in the sample. The highlighted dot corresponds to a 45-year-old worker who earns $49.15 per hour. The data are for computer and information systems managers from the March 2016 capitals CPS. The sample covariance and correlation are estimators of the population covariance and correlation. Like the estimators discussed previously in this chapter, they are computed by replacing a population mean, the expectation, with a sample mean. The sample covariance, denoted as sub big X big Y, is S sub big X big Y equals 1 over n minus 1, the sum of I equals 1 to n of open big X sub I minus big X bar close open big Y sub I minus big Y bar close, equation 3.24.